All right, let's go with section 5.1, operations with functions. So start off with a little bit of a word problem here. If we were in class, I would take and do some yo-yo tricks, but we're not. So I guess I'm just going to redo the problem. So back in the day, Mr. Krusty owned a yo-yo store. That's actually not true. It's just for the problem here. But anyway, he's been a yo-yo enthusiast since about second grade. Suppose that his revenue is given by this function, f of x equals 4x to the 1 half, and his expenses are given by g of x equals negative 9x to the 1 half. What equation will tell him profit? So the idea here is that if you want to know your profit, you're going to take all of your revenue, all of the money that comes in, and you're going to take away all of your expenses. Whatever's left over will give you profit. Okay, and if those things vary over time, then a function might be a better way to model it than just a number at a given instant. So what equation will tell him his profit? Well, he's going to take revenue minus expenses. And in our example here, that is f of x minus g of x. F of x is 4x to the 1 half minus a negative 9x to the 1 half. And so that's going to be 13x to the 1 half. Okay, so there's our equation, or our function that models profit. Okay, so what we've done here is we've done an operation to these functions. We've subtracted them. Okay, and it turns out that you can do a number of operations with functions. You can subtract them, you can add them, you can multiply them, you can divide them. You can take one function and put it into another function. You can take a function and put it into itself. You can do this for functions generally, like we did here. We can do it for specific points. That's what we're playing around with in section 1 and section 2. Okay, so let's just jump right into an example here. Functions can be added, subtracted, multiplied, and divided. Find the following given. F of x equals 5x, g of x equals x plus 2. So f of x plus g of x, that's just going to be taking and substituting in for f and g, the functions that were given. So that's 5x plus x plus 2. Okay. Combine like terms here. 5x plus x is 6x plus 2. And that's it. Going on to the next one. And these are ones where you should pause the video and give it a try first. So going on to the next one, f of x minus g of x. So that is going to be 5x minus x plus 2. Be careful, we'll have to distribute the negative through this whole thing. So 5x minus x is going to be 4x and then negative 2. Really easy to forget, especially in a multiple choice test. You know that 4x plus 2 is going to be on there. So take your time on those. F of x times g of x. Well, that's just going to be 5x times x plus 2. That's going to be 5x squared plus 10x. Nothing left to do there. And the last one is division. Quite often with division, there's not a ton of work to do once you've set it up. So we'll see in this one, f of x is equal to 5x divided by g of x, which is x plus 2. And in this one, there's nothing to do here. Just leave it. So sometimes there won't be that much simplification. All right, now here we've written it out really explicitly. F of x times g of x. Really easy to figure out what you want, what we're looking for in that problem. Sometimes, in fact, most often, the operations on functions will be written in this way, where instead of writing x twice, we just write f times g in this example, f divided by g in this example. Where we just write that and put it in parentheses again, as opposed to writing x twice. All right, so this one, f times g of x, is going to be equal to x squared plus 7x plus 12. You always want to be careful. You always want to use parentheses. Times 3x minus 4. All right, and then to multiply this out, I'm going to use the box method. And I realized that I didn't give myself a ton of space to do this. But we're going to try it. So 3x, negative 4 here. X squared plus 7x, positive 12 across the top. So I'll have 3x times x squared, that's 3x cubed. 3x times 7x, that's 21x squared. 3x times 12, that's 36x. X squared times negative 4 is negative 4x squared. Negative 4 times 7 is negative 28x. Negative 4 times 12 is negative 48. And then we're just going to combine like terms. So what I end up with here, and I'm definitely going to run out of space, aren't I? 3x cubed. This would be negative 4x squared plus 21x squared here. Those are like terms, so that would be 17x squared. Here we've got 36 minus 28, that is 8. 8x. And then the last one, the constant term, is minus 48. Okay. So again, apologize for not giving you enough space here. I could have worked this in a different way, obviously, so that there was enough space. My mistake. All right, f over g of x. So this means we're going to do division. So I'm going to take f of x, which is x squared plus 7x plus 12, divided by 3x minus 4. And that's it. Like I said, most of the time on division problems, I don't want to say all the time, but most of the time, you're just going to set it up and you're just going to leave it. Okay. Now, this one is a little bit different. This one we want f times g of negative 1. Now this is equal to f of negative 1 times g of negative 1. Okay, so if we multiply those things together. So we need to figure out what f of negative 1 is and g of negative 1 is. So f of negative 1, if we look at our graph, that's going to be the function value at negative 1. So here's negative 1 right here. F of negative 1 will be this value, which is 1. So f of negative 1 equals 1. And then g of negative 1 will be the function value of g at negative 1, which is right here at negative 2. Okay, so g of negative 1 is equal to negative 2. So when I multiply these things together, I'm going to get 1 times negative 2, which is just negative 2. Okay. Boy, I really didn't do a good job with spacing on this. Sorry about that. All right, number 4, last one here. Some of the questions will ask you for the domain of the function that you find after you do some operation on the functions, okay? And this one is asking us, what is the domain of the function you found in number 1, part D? So that's the domain of this function right here. So I'm just going to rewrite it here real quick. This was f over g of x, and we got 5x over x plus 2. Now, one way to figure out what the domain is to graph it and look at all of the x values that are covered by the graph. But I'm going to give you a shortcut. I'm going to give you a hint. Functions that are fractions, call them rational functions, those functions will have a domain of all real numbers except for numbers that when we plug them in, except for values that make the denominator 0. Okay, so and this is because we can't divide by 0, right? In this function, if I plug in negative 2, I will get a divide by 0 error. So this function will have domain of all real numbers. Everything will work. You can plug in 7, pi, a trillion, whatever you want in for x. And there will be a y value that comes out the other side, except for negative 2. So we'll write all real numbers. You can write it out if you want. I'm going to use a fancy R. All real numbers, except x can't be negative 2. Okay. So that's one way to write it. You can also write, if you don't want to write like that, you can also write x is greater than negative 2 and x is less than negative 2, but it seems like a little more work. Usually students just like to write everything except for where it's missing. Okay, and that's it for section 5.1. The main thing, putting functions together, simplifying, doing that a bunch, and then this type of function where, or this type of example where you figure out what the f value is wherever you're looking, the g value is wherever they're looking, and then you do the operation. It won't always be multiply, it could be add, subtract, multiply, or divide. And that's really all there is to section 5.1.